Hello, algebra geometry students. This is Mr. Brown again. We're going to go through the answers to the geometric probability for Tuesday's assignment. So, first off, the number line problems. If a point is on segment AE, so if it's from here to here, somewhere in that section, find the probability it's on AB, which would be from here to here. So when we think about probability, it is part over whole. The whole bit would be AE, going the entire way. So that denominator would be 9. The part, the AB, would be this section here, from 0 to 2. So that would be 2/9. And that is the answer. Number 2, you might want to pause it right now to see if you can figure out how to do 2 on your own. And here we go. So same idea here. It's going to be part over whole. So it's on segment AE. That's the same segment going from here to here. So our denominator is going to be 9. Find the probability it's on BD. So from here to here. From B to D, from 2 until 7 is 5 units long. So that makes 5/9 our answer to that question. If a point is on segment AC, find the probability it is on AB. So AC goes from here to here. That is 3 units long. AC from here to here is 3 units long. Find the probability it is on AB. So we want to find out how long AB is, and that's going to go in our numerator. A to B is here to here. That is 2 units long from 0 to 2, making our answer 2/3. And finally, if a point is on BD, find the probability it is on BC. So BD goes from here to here, from 2 to 7. That is 5 units long. You notice I always get the denominator first. I just think that's kind of a good way to go to set up the problem. Find the probability it's on BC. So from B to C, from here to here, that's only 1 unit long. Those are right next to each other. So it's 1/5. And just to get some conceptual understanding of this, if you think about this whole length here, 1/5 of the time, 20% of the time, we would end up with a value in that section. So that's what the probability is, just the likelihood that if it's from here to here, that we would end up over there. Okay, on to the next problems. Probability using area. So if a point is on rectangle ABCD, so if it's on this whole rectangle, find the probability it is on square AEFG. AEFG. So that would be this square here. You'll notice I put some formulas down here at the bottom for you for the 4 different shapes that are on this page. So it's going to be part over whole again here. The whole, in this case, is going to be the whole rectangle. So the rectangle is 10 by 8. That is 80 area, because 10 times 8, which is the area of a rectangle, is 80. The part is going to be the square, the shaded region over here. Probability in that square. The square is found by doing 3 times 3. 3 times 3 is 9. So I'm going to put 9/80 right there. Okay, now for number 6. If a point is inside the triangle, find the probability it is inside the circle. So we are going to have part over whole again. The whole is going to be the full area of that triangle. You can see triangle formulas: base times height divided by 2. So that would be 8 times 10 divided by 2. That is 40. The part is the circle. So if we take a look at that circle there, the formula for circle is pi r squared. The radius goes from the center to the outside, so that's 2. So I'm going to do 3.14, which is pi times 2 squared. And then using a calculator, 3.14 times 2 squared is 12.56. and I'm going to divide that number by 40 to get the decimal of, hey, how about that, 0.314 probability. Okay, moving on to the next and final worksheet. The challenge problems. If a point is selected in the square, find the probability it is in the circle. So the probability that's in the circle here. So part over whole. The whole is going to be the area of the square, which is 100. The part is the pi r squared, so 3.14 times 5 squared. Let's find out what that is. $78.5. Which becomes 0.785 as a final decimal answer. Find the probability it is in the square but not in the circle. So what we're talking about here is the outside parts. All added together. If you think about the diagram here, we have a square and a circle. This outside part would be the square minus the circle. We know the square is 100, and we know the circle is 78.5. So those outside parts must combine to be 100 minus 78.5, which is 21.5. So the part here is the not in circle part divided by the whole, which is the square. The part not in the circle, because 100 minus the circle is 21.5, is 21.5, and the square is 100. .215. Now for the super challenging question at the end. If the square had side lengths of 8 and the circle had radius 4, would the answers to 7 and 8 be the same? So would these answers be the same if we just change these numbers to be 8 here and 4 there? Well, the answer is yes, it would be the same. And there's a couple ways of getting this. One, you could actually just do the math out. You could do 8 squared, 64. You could do 3.14 times 4 squared, and when you do that math, you get 0.785 again. So you could prove it using mathematics like that. You could also just kind of write a sentence saying that the diagram would look exactly the same if that were 8 and that were 4. The labels would be different, but because the diagram is exactly the same, the probability of being inside the circle would be the same as it was for 10 and 5. So you could also explain it in a sentence like that. Hope you understood all this. Have a nice day.